In quintessence models of dark energy, the observed acceleration of the scale factor is caused by the potential energy of a dynamical field, referred to as quintessence field. Quintessence differs from the cosmological constant in that it can vary in space and time, in order for it not to clump and form structure like matter. The field must be very light so that it has a large Compton wavelength. In the simplest scenarios, the quintessence field has a canonical kinetic term, is minimally coupled to gravity, and does not feature higher-order operations in its Lagrangian. No evidence of quintessence is yet available, but it has not been ruled out either. It generally predicts a slightly slower acceleration of the expansion of the universe than the cosmological constant. Some scientists think that the best evidence for quintessence would come from violations of Einstein's equivalence principle and variation of the fundamental constants in space or time. Scalar fields are predicted by the standard model of particle physics and string theory. But an analogous problem to the cosmological constant problem, or the problem of constructing models of cosmological inflation, occurs. Renormalization theory predicts that scalar fields should acquire large masses. Quote, "The coincidence problem asks why the acceleration of the universe began when it did. If acceleration began earlier in the universe, structures such as galaxies would never have had time to form, and life, at least as we know it, would never have had a chance to exist." Proponents of the anthropic principle view this as support for their arguments. However, many models of quintessence have a so-called tracker behavior, which solves this problem. In these models, the quintessence field has a density which closely tracks, but is less than, the radiation density until matter radiation equality, which triggers quintessence to start behaving as dark energy, eventually dominating the universe. This naturally sets the low energy scale of the dark energy. In 2004, when scientists fit the evolution of dark energy with the cosmological data, they found that the equation of state had possibly crossed the cosmological constant boundary. W equals -1. From above to below. A no-go theorem has been proved that this scenario requires models with at least two types of quintessence. This scenario is the so-called quantum scenario. Some special cases of quintessence are phantom energy, in which the energy density of quintessence actually increases with time, and K-essence, short for kinetic quintessence, which has a non-standard form of kinetic energy such as a negative kinetic energy. They can have unusual properties. Phantom energy, for example, can cause a big rip. A group of researchers argued in 2021 that observations of the Hubble tension may imply that only quintessence models with a non-zero coupling constant are viable.